Welcome to Dangerous Prototypes. I'm Ian.
I'm Sjaak.
Today we're here in Sjaak's workshop, and he's really excited because he's got a new display project he wants to show us.
Well, it's based on little TFTs we found on eBay. Like several others, Adafruit has got some. I think even Sparkfun has. It's a very cheap LCD. It's got 160 by 128 pixels. It's got full color, and I think it's so much cooler than just a regular 16 by 2 or whatever LCDs people tend to use. One of the main features is of course the LCD. It also got some little buttons for simple GUI stuff. On the back side it got a little microcontroller. It's based on the PIC 18F24J50.
And that's the same one that's in the Logic Sniffer and a few other
In
projects.
most of our projects. It's also capable of running our version of the USB stack. It's got a little card holder for a micro SD card. Currently it's running in matrix orbital mode. It's a very common serial protocol to address LCDs. I'm running Linux with LCD proc, and also it should be compatible with Smarty, I guess, on Windows.
Yeah, LCD Smarty is the one under Windows. Yeah, so what you're doing here is you've got a graphic LCD, but you're using the matrix orbital protocol, so it pretends to be the classic HD 44780 character LCD.
Yeah.
So it could be a graphic display that can replace those old, bulky, power-hungry displays.
Yeah, it is.
Very cool.
Due to it's larger than 16 by 2. It's 26 by 14.
Well, that's a lot. I
Yeah.
mean, the most I've ever seen before is what, 40 by 4, basically.
Yeah.
The 20 by 4 is sort of the standard, and then the 40 by 4 is the
It's
biggest. So you've already got more lines than any other display out there.
This is the back side of the PCB. It's got connection for mini USB. Also, you can solder it directly to it. So if you want to install it inside your computer, you can use those connections. Also, it's got the ISP connector, very simple.
So you can program the PIC.
Yeah.
Yep.
Also, the buttons, which can be soldered directly with wires, so you could put them somewhere else, which is perhaps more convenient. Over here, it got the power broken out. The downside of most projects that broken out power is just one ground and one positive voltage, so I make it two.
So you did multiples. Nice.
Yeah.
Nice. That's
and
handy.
here it got 4 pins that aren't used with the current setup. Can be used for other things. For example, most pins, I guess all, or at least 3 are ADC pins.
Okay.
So you get an analog in, voltage in.
Okay.
Also the chip got peripheral pin select.
And that's the feature where you can take a piece of hardware and move it to another pin.
Yeah.
Yep. Okay.
Select.
So on these extra pins, you can have them be SPI,
Whatever,
or a UART, or a timer, or pulse width modulator.
pulse width modulator.
Very cool.
Yeah. So you can actually make, for example, a PD controller for an oven to reflow, or soldering.
Everything comes back to a reflow oven, doesn't it?
It always does.
Well, you've already got the display, and you've got an SD card. You could load heating profiles right up, and just have your PID controller and temperature measurement.
Okay.
Definitely.
As I told before, it has 4 buttons. The top one is the plus, or move up. The next one is move down. The next one is OK, to confirm things, and a back button to go one step back. Over here it's the ADC mode. It's basically a little, like oscilloscope, but very slow. This is the current voltage measured on one of the ADC pins. It's connected to a diode, which is during room temperature. It got about a voltage drop of 0.7 volt, but the voltage drop depends on the temperature. So if it's got hotter, the voltage drop become less. Here it's at room temperature, and I'll go use a lighter, and we should see a voltage drop.
Got a bit of a smoking diode there.
Yeah. I guess it's the last thing this diode ever does.
That's a great demo. So it's connected up to one of the analog digital converter pins. You're measuring the voltage from it, and when you heat it up, the voltage drops, and you're showing it on the screen.
Yeah.
And so if you were to put it into a frosty beer, you would expect it to go higher? Okay. How did you design the self-test?
Well, the self-test is just basically initialize the display, show some colors. After that, show the status of the buttons. And also it will enumerate as a simple serial device.
So the idea is it's a way the factory can test every feature of this board quickly and easily.
Yeah, the speed is not capable of showing videos, but it's okay for a simple menu system, showing heat profiles or whatever. Yeah. Or for the part ninja, show the pinout of the currently loaded transistor.
Yeah, I mean, ultimately our goal is to get a standard carrier board so that we can use this sort of LCD instead of the bigger, heavier, more power-hungry, 5-volt needing HD character LCDs and move to that in all the projects, including the Part Ninja and a few others. This isn't the first revision of Sjaak's display, so I've asked him if he would haul out some of the ones that he made along the way that didn't quite work out. And tell us a little bit about them.
Actually, the first one I threw out immediately. It had the display backwards. It was mounted like this, and then.
Yeah, can you explain your air wire job there?
Here I switched the MOSI and the MISO singles.
Well, it looks like it turned into a great project. I especially like the HD 44780 compatibility.
Okay. So one thing we forgot to mention, it's designed to fit in a drive bay, in a 5.25 drive bay.
Okay. So it's designed to fit into the drive bay of a PC case, like the kind of a DVD drive would go into. And do you have any other projects that you'd like to show us?
Not yet.
I would say let's take a quick look at this one though. I just wanted to show you this one too. What we've got here is Sjaak built up the very first revision of the ATX breakout board. This is his original prototype for this design.
Most breakouts just got one ground pin. It's got ground pin for every connection. The downside is a little bit of it is more dense than the current one.
ATX connector there that comes over, and you can notice the resistor, the load resistor is back behind it instead of in front of it like it was on the final board. Okay. And this one is also not in the DP standard Sika beige board format.
Well, it's just the maximal allowed.
It's so an earlier draft.
Yeah. But only the Sika beige gets the round corners. This one straight. This is the current revision.
And you can see we've now got this right angle ATX connector, load resistor moved in front. All the voltage is brought up. We've still got the 2 grounds, so we have more than 1 ground, but
I'm sorry about
we're not populating those.
Okay.
That's not an insult. It's okay. We had to keep the cost down, and that was one way to do it. And now I guess we've made up version 1.3 now with a few minor tweaks, including a fuse blown indicator, and we broke out the LEDs and all the signals and including the on-off switch to a header. Okay. So that people can tap into those. So if you want to put it into a case or something, you can tap into those signals and move them to the outside of the case easier. A huge thank to Sjaak for showing us around his workshop and showing us the various revisions of the LCD board, as well as the history behind the very popular ATX breakout board. Thank you so much, Sjaak.
Okay, you're welcome anytime.
And we'll be back in the workshop next week. Thank you for watching.
Bye-bye.